A Chinese spacecraft has made the first successful landing ever on the far side of the moon. And this is what it looks like.
For thousands of years, one half of the moon has stared down at us in silence. It has watched civilizations rise and fall, witnessed the birth of science, and hung above every human who ever looked up and wondered what was out there. And yet, until very recently, we had never once seen the other side. Not a photograph, not a single footprint, nothing. The far side of the moon was the last great mystery in our own cosmic backyard. And then China decided to go there, not for prestige, not for headlines, but for a reason far more calculated, far more strategic, and honestly far more shocking than most people realize. Because what China was really after on the far side of the moon wasn't just rock and dust, it was something that could change the future of energy, civilization, and the balance of power on Earth itself. Let's start with why the far side exists as a mystery in the first place. The moon is tidally locked to Earth. Its rotation and orbit are perfectly synchronized, which means one face always points toward us and one face always faces away. For all of human history, that far side was invisible to us. Even with telescopes, even with satellites, we could never see it directly from Earth. And more than just being hidden, it's also completely cut off from Earth's radio signals. The bulk of the moon blocks all communication. That means you can't simply land a spacecraft there and phone home. You can't send commands. You can't receive data. You are, for all practical purposes, completely alone on the other side of a 380,000-kilometer rock. That's exactly what made it so hard to reach and exactly why no one had ever done it, until China cracked the puzzle in a way that changed everything. In 2018, a year before the landing itself, China quietly launched a relay satellite called Queqiao, which means Magpie Bridge. They placed it at the Earth-Moon L2 Lagrange point, a spot of gravitational balance hovering beyond the moon where it could maintain a permanent line of sight to both the far side and Earth simultaneously. It was an elegant solution to an impossible problem. A cosmic communication bridge stretched across the void. And once that bridge was in place, the door swung open. In January 2019, China's Chang'e 4 lander descended through the darkness and touched down inside the von Karman crater, deep within the South Pole Aitken Basin. It became the first human-made object in history to land on the far side of the moon. But here is the question nobody seemed to ask loudly enough. Why? Why spend years and billions of dollars building an entirely new communication architecture just to land in a crater most people had never heard of? Why not go back to the near side where every other nation had explored? Why go to the one place that made everything exponentially harder? The answer begins with what sits beneath that crater floor. The South Pole Aitken Basin is the largest known impact structure in the solar system, 2,500 kilometers wide, 8 kilometers deep, and so old that it formed before many of the moon's surface features even existed. When the asteroid that created it hit, it didn't just leave a dent. It punched through the crust and into the lunar mantle, the deep interior layer that had never been exposed to the surface before. For scientists, this was not just a landing site, it was a time capsule, a geological window into the moon's violent birth and, by extension, the formation of our entire inner solar system. And when Chang'e 4's Yutu-2 rover rolled onto the surface and began scanning, it detected olivine and low-calcium pyroxene, minerals that don't belong in the crust. These are mantle materials. For the first time in history, humanity was analyzing the deep interior of the moon without having to dig for it. The asteroid had already done the excavating 4 billion years ago. But that discovery, as profound as it was only part of the story. Because what? The far side samples revealed next completely overturned one of our most fundamental assumptions about the moon. The accepted theory had always been that the far side should have cooled faster than the near side. In the early solar system, when Earth was still a boiling volcanic hellscape, it radiated enormous heat toward the near side. The far side got none of that warmth. It faced the cold of open space. So scientists fully expected to find the oldest, most ancient volcanic material on the far side, frozen in time billions of years ago. And they did find ancient material. When Chang'e 6 returned far side samples to Earth in 2024, one fragment of volcanic rock dated back 4.2 billion years, the oldest moon rock ever discovered. Ancient, just like the theory predicted. But then came the shock. The same mission also found rocks that were far younger. The average age of the far side volcanic samples was 2.8 billion years. That is younger than most of the near-side rocks collected by Apollo astronauts, which typically came in at over 3 billion years old. Think about what that means. The side of the moon that was supposed to have frozen first, the side with no warmth from Earth, stayed geologically active longer than the side that did. The moon stayed hot and molten for far longer than anyone had imagined, and scientists are still trying to figure out why. Now, while the far side was yielding those geological surprises, another Chinese mission was making a discovery on the near side that shifted the entire frame of this story. In 2020, Chang'e 5 returned to Earth carrying 1.7 kilograms of lunar soil, the first fresh samples brought back in over 40 years. And inside that gray dust, something extraordinary was waiting. A new mineral, a tiny transparent crystal, smaller than the width of a human hair. Scientists had never seen it before on Earth or the Moon. They named it Chang'e Y, making it the 6th new mineral ever discovered on the Moon. But the name was the least interesting thing about it, because hidden inside its atomic structure were traces of helium-3. And that is where the story of China's lunar ambitions takes a turn that goes far beyond science. Helium-3 has been described as the most valuable resource the Moon has to offer. It is an isotope that comes directly from the Sun, carried to the lunar surface on solar winds over billions of years. Earth's magnetic field blocks solar wind from reaching our surface, which is one of the most important reasons life here exists. But the Moon has no magnetic field and no atmosphere. It has been soaking up helium-3 for eons, and the lunar regolith is packed with it. Scientists estimate that over 1 million tons of helium-3 sit locked in the Moon's surface material. To put that in perspective, just 40 grams of helium-3 contains as much energy as 5,000 tons of coal. And unlike conventional nuclear fuel, helium-3 fusion produces virtually no radioactive waste. It is clean, it is efficient, and it could theoretically power Earth's civilization for tens of thousands of years. The technology to harvest that energy, a working helium-3 fusion reactor, does not exist yet, but the entire scientific community agrees it is a matter of when, not if. And when that day comes, whoever controls the Moon's helium-3 deposits will hold the keys to the most powerful energy source in human history. This is the context in which China's decision to go to the far side starts to look less like scientific curiosity and more like strategic positioning. The far side of the Moon receives more direct solar wind exposure than the near side. It is geologically ancient, meaning its surface materials have had billions of uninterrupted years to accumulate solar wind deposits. And it sits adjacent to the South Pole Aitken Basin, one of the deepest and most ancient regions on the Moon, where helium-3 concentrations may be among the highest anywhere. China wasn't just planting a flag, they were conducting reconnaissance on the most valuable real estate in the inner solar system, mapping it, studying it, and learning how to operate within it before anyone else arrived. But there is one more discovery from China's missions that adds another layer to this picture entirely. When Chang'e 5 collected its samples, scientists found something unexpected in the volcanic rock: water. Not hydrogen and oxygen nearby each other. Actual bonded water molecules, real H2O, found inside a hydrated mineral called ULM1. And here's the part that stunned researchers. This wasn't found at the poles inside the permanently shadowed craters where everyone assumed lunar water would be locked away. It was found on the side of a young volcano in a geologically active region near the equator. That changes everything we thought we knew about water distribution on the Moon. If water isn't just trapped at the poles, if it's chemically bonded into minerals spread across the surface, then the Moon is far more resource-rich than our models ever suggested. And a water-rich moon is a moon where you can make oxygen to breathe and hydrogen to use as rocket fuel. It becomes not just a destination, but a launching platform for everywhere else in the solar system. All of this points to a conclusion that is hard to escape. China didn't go to the far side of the Moon simply for the science, though the science has been extraordinary. They went because they understood earlier than most that the Moon is not a trophy. It is infrastructure. The helium-3, the water, ice at the poles, the ancient geological record, and the strategic advantage of being the first to operate in the most inaccessible corners of the lunar surface. These are the real reasons. Chang'e 7 is already preparing to target the South Pole in 2026 to confirm and map those water ice deposits. Chang'e 8 follows in 2028 to test 3D printing with lunar soil, laying the literal groundwork for a permanent base. And a crewed landing before 2030 is not a distant dream. It is a scheduled milestone on a roadmap that has never once missed a step. Half a century ago, the space race was about ideology. It was about which system could plant a flag first. Today, it is about resources, presence, and the kind of quiet, methodical accumulation of capability that changes the balance of power slowly and then all at once. China understood something about the far side of the moon that most of the world was too slow to realize. That the most mysterious place in our neighborhood was also the most strategically important. And by going there first, by building the bridge, landing in the dark, and studying what lay beneath the silence, they didn't just make history. They put down roots in the future, so the question now isn't whether what China found on the far side is significant. It clearly is. The question is whether the rest of the world woke up in time to understand what that really means. What do you think? Is China already too far ahead in this new space race? Or is there still time for others to catch up? Let us know in the comments below.